Good morning, students. As in the previous video, we had discussed about the terms position, frame of reference, path length, displacement, certain numericals based on this. All things we had discussed in the previous video in continuation with our chapter number 3, that is motion in a straight line. So today in this video we are going to discuss about certain differences between distance and displacement. So look at here and see the basic differences between distance and displacement. Difference between distance and displacement. Difference between distance and displacement. So here I am writing distance and here displacement. The first point of difference is that length of the path is called distance. As we had discussed, whatever the path length, that path length is called as distance, and displacement is the magnitude of displacement is the shortest path. Magnitude of displacement is the shortest path. Shortest path between 2 points is the magnitude of displacement. It is a scalar quantity, and it is a vector quantity. It has direction and it has only magnitude but no direction. Distance can never be zero. Distance can never be zero, but means if there is the passage of time, then you can't say that with the passage of time the distance traveled by an object will be zero, but displacement of an object can be zero. Displacement of an object can be zero. Means with the passage of time, if the body is traversing some distances and it comes again to its initial point after traversing certain distance, then in that case the displacement of the object is zero. Next difference is distance is always positive. Distance is always positive. Distance is always positive. Displacement can be positive, negative and zero. We had discussed it. displacement can be positive, negative, or zero. Displacement can be positive, negative, or zero. So these are certain differences. You can write it as in this way also. The next difference, if you want to add here, then you can say that distance must be equal to or greater than displacement, and here you can write that displacement is equal to distance or less than the distance, never be greater than the distance covered by the object. So these are the differences to be noted down between distance and displacement. Now we will discuss about motion, uniform motion in straight line. Uniform motion in straight line. What is the meaning of uniform motion in straight line? Uniform motion in straight line. Uniform motion in straight line. Uniform motion in a straight line means to say that if an object travels equal distances in equal interval of time, if an object travels equal distances in equal interval of time. If an object travels equal distances in equal interval of time along a straight line, along a straight line. For example, suppose there is a car. And this car is running at 10 meter per second or 10 kilometer per hour. 10 kilometer per hour. This car is running at 10 kilometer per hour. It means to say that what? It means to say that first hour it travels 10 kilometer. Second hour it travels 10 kilometer. Third hour it travels 10 kilometer, and so on. Means in each hour the car is moving 10 kilometers. And this car is moving in a straight line. Means the motion opted by the car is a uniform motion. The motion opted by the car is uniform motion. So we want to draw for the uniform motion, we want to draw the distance time graph for the motion in a straight line. Distance time graph for motion in straight line. Distance time graph for motion in a straight line. Distance time graph for motion. So here you are seeing two variables. One variable is distance and the other variable is time. So if there are two variables, means time distance is proportional to time, and as time is going to be increased, the distance is also going to be increased. And if there are two variables, then in mathematics you had studied that if there are two variables, then you can easily plot the graph between these two variables. You can easily plot the graph in these two variables, time in second and distance in meter. These are the two variables. And if I'm taking an example, then object is moving with 10 meter per second. 10 meter per second means 10 meter in every second. 10 meter in every second. So this is origin 1 second, 2 second, 3 second, 4 second, 5 second, and here 10 meter in first second, 10 meter, 20 meter, 30 meter, 40 meter, and then 50 meter. This is distance in meter. Now look at here. In first second, the object covers the distance of 10 meter, in second 20 meter, in third second 30 meter, in fourth second 40 meter, in fifth second 50 meter. So what you have observed, what type of graph you had got? You had got the graph having a slope, constant slope, making an angle theta, and this is the straight line graph. This is the straight line graph, and for the moving in a straight, for a body moving in a straight line, you can say that for a body moving in straight line, distance covered by the object is equal to its displacement. Distance covered by the object is equal to its displacement. Since it is a straight line, so it has direction, so you can say that the distance covered by the object is equal to the displacement. Now there are two cases here. If the object is at rest, then what is the position time graph? Can you guess what is the position time graph for the object at rest? First case is when the object is stationary. When the object is stationary. Stationary means rest. Means when the object is at rest. Object is at rest means what? If the object is at rest means to say that time is increasing and distance is fixed. Means the distance of the object from the reference point is always fixed with respect to the increase in time. For I'm clearing this scene with an example. Suppose you are observing your friend from the school office, and your friend is standing at a school gate, and the time passes, and with the passage of time your friend remains himself at the school gate with the passage of time. He is not changing with the position from the reference point, that is the school office. So your friend is said to be rest with the passage of time, and in this case you can say that this is time in second and this position is meter. So this is your reference point, and with the passage of time at t is equal to 0 second, x is equal to 2 meter, at t is equal to 1 second, x is equal to 2 meter, at t is equal to 2 second, x is equal to 2 meter, at t is equal to 3 second, x is equal to 2 meter. So this is the graph, that is the fixed graph, and this is the graph for a stationary object. When the object is moving with variable motion, when the object is variable motion, moving with variable motion, variable motion means to say that unequal distance in equal interval of time. Variable motion. Unequal distance in equal interval of unequal distances in equal interval of time. So how can, suppose for at t is equal to 0 second, the position of the object is 0 meter. At t is equal to 1 second, 5 meter. At t is equal to 2 second, the position of the object is 7 meter. At t is equal to 3 second, the position of the object is 8 meter. Means the change in position of the object is not fixed. Somewhere the object is moving very fast, somewhere the object is moving slowly. So the distance covered by the object is not fixed, and in this case the position time graph, here it is time in second and here the position in meter, and the distance time graph in this case is just like a zigzag motion, and this is the position time graph. Unequal distance in equal interval of time. Somewhere it covers less distance, and after that it covers more distance in the same interval of time. Now we are going to discuss about non-uniform motion. Non-uniform motion. Non-uniform motion is similar to variable motion, and if the object travels equal displacement, if the object travels equal displacements in unequal interval, object travels equal displacement in unequal interval of time. This is non-uniform motion, and you can draw the graph for non-uniform motion. There is on this axis time in second, and on this axis distance is meter, and just like this graph, this graph is of non-uniform motion. Now we will try to solve a question based on this. I think all of you had got the clear idea about motion, different type of motion, uniform motion, non-uniform motion, distance, displacement, all things had been clear to you. Now look at the question. An object starting from plus 10 meter on the x-axis covers 20 meter in first second and 30 meter in the next second towards positive x-axis. Draw the position time graph. Draw the xt position time xt. Draw the position time graph. Look at the question. An object is starting from plus 10 meter on the x-axis. Plus 10 meter on the x-axis and covers 20 meter in first second and covers 20 meter in first second and 30 meter in next second, 30 meter in next second towards positive x-axis. Positive x-axis. Draw the position time graph. Look at the position time graph. Mark it at y-axis. Covers 20 meter in first second and 30 meter next towards positive y-axis. And then draw xt graph. So here x in centimeter and time in second. So this is 0 plus 10 plus 20 plus 30 plus 40 plus 50 and then plus 60, and the time is 1 second, 2 second, 3 second. So what is the plus 10 meter on positive y-axis? Starting from here, the object is starting from here and covers 20 meter in first second. So this is first second and it covers 10, 10, 20 meter. 20 meter in first second and 30 meter in next second. 10, 10, 30. This is, so the graph will be like this. This is the nature of the graph. This is the nature of the graph for the first second, first 20 meters, second, all these things. Now we will discuss about, the next discussion is velocity. What is velocity? And then we will discuss about velocity. What is velocity? before discussing velocity, I want to discuss speed. We discuss speed and then we will discuss velocity. First, what is speed? Speed, as you know that distance covered per second, we are generally used to say 10 meter per second is the speed. You had generally observed the saying that a bowler is throwing the ball at 110 kilometer per hour. 110 kilometer per hour means, it means to say what? In 1 hour distance covered is 110 kilometer. In 1 second distance covered is 10 meter. Means how much distance covered by the object per second, how much distance covered by the object per second. So it can be defined as the path length covered or distance traveled by the object. The path length covered or distance traveled by the object in a given time interval. Path length or distance covered by the object in a given time interval. So speed is what? Speed is nothing, it is the distance. These are the basic things you had already studied. Distance covered upon time taken. Since distance is a scalar quantity, it has no direction, so speed is also a scalar quantity. Speed is a scalar. Speed is since distance is a scalar quantity, so speed is a scalar quantity, and as distance is always positive, distance cannot be negative or zero, so speed is always positive. So speed is always positive as distance is positive, so speed is always positive, and its SI unit is meter per second. Since the SI unit for distance is meter and time is second, so SI unit is meter per second, and CGS unit is centimeter per second. CGS unit is centimeter per second, and its dimensional formula is dimensional formula there is no m0 distance L t minus 1, m0 L t minus 1. Uniform speed, two types of speed. Uniform speed means to say that of equal distances in equal interval of time. If an object travels equal distance in equal interval of time, equal distance in equal interval of time means first second 1 meter, second 1 meter, third second 1 meter, means its speed is 1 meter per second. So this is uniform speed, and the next is non-uniform speed. Non-uniform speed, just opposite to this, unequal distances in unequal interval of time. Equal distances in unequal interval of time. Unequal distances, equal distances, or you can say that unequal distances in equal interval of time, or unequal distances in equal interval of time, means in first second 1 meter, in second 3 meter, in third second 6 meter, in fourth second 7 meter. In first second the speed is 1 meter per second, in second second the speed is 2 by 3, 3 by 2 meter per second, in second 2 meter per second, means in each time interval the speeds are different. So this type of speed is called as non-uniform speed. So that's all for today, students. In the next video we will discuss about velocity, uniform velocity, what is velocity, what is uniform velocity, what is its dimensional formula, what is the unit of velocity, and after that we will discuss 2 or 3 numericals based on this, and then we will move towards average speed and average velocity. So that's all for today, students. Thank you. Take care. Have a good day.